Hey guys, and welcome to my picoCTF series. Today we're going to be looking at the easy peasy cryptographic challenge. It's hasn't been too easy, and it's taken me quite a few attempts to get this video right, but this is one that's going live. I can feel it. So the first thing that you'll notice with this challenge is that there's two resources. There's the netcat command and the OTP Python script. Now, the Python script I've already downloaded, and you can see it's here. And I also have looked at the endpoint, which this looks like an instance of this Python script running on a remote machine. And I'm pretty sure this is the case because we've got the same kind of output here, and yeah, it looks like there might be a flag file on the remote host as well as a key file, which is why we're getting this output. We obviously don't have that locally, so if we ran this Python script here, it complains that we're missing a flag file. So we should probably do something about that, but let's just see what's going on here. It looks like we can encrypt arbitrary data, and it looks like as we encrypt the same data, the key file, there's different parts of the key file are being used to encrypt this data. So that's fine. Let's have a look at this again. So we can see that there's a key file, we can see there's a flag file. These files will obviously be present on this remote instance, but we don't have file system access, so we can't see the contents of the flag or the key files. Okay, if we look at what's going on here, the first function that's being called is the startup function, which is here. And what's happening here? The flag file is being opened, the key file is being opened. The start is set to 0 because the key location in this function, as called, is 0. And then the stop becomes 0 plus the length of the flag. That's fine. The key becomes the key file from start to stop. So it's basically saying I want X number of bytes from the key file, which is the same as the number of bytes in the flag. Okay, and once I've got the key location becomes stop, which is the length of the flag in this case, and then we're outputting the result, which is in hex, and we're doing an XOR operation on the flag and the key file. So XOR is quite common when it comes to encryption. It's a very common operation. So we see here that the encrypted output is there, and then finally we're returning the key location, which is an integer from startup, and that is then being used in a while loop on repeated calls to the encrypt function. So you'll see here I've already started debugging this, but if we run this Python OTP, let's create a flag file. So we'll create a flag file which will contain 32 A's. Okay, we'll specify the end as nothing, pipe that into flag, and then we'll also create a key file which will be 50,000 characters of 0. Okay, now if we run this again, we have some data. Now this output is from startup function. This is from the encrypt function, and you can see the key location here is 32. Now, why do we care about the key location, you might ask? Well, if we can make the key location for this encrypt function equal 0, we can get the program to use the same set of bytes from the key file that it used to encrypt the flag here. Okay, why is that important? Well, if we can control the message that's being encrypted with the one-time pad, and if we can get the result of, if we can get the encrypted message out, then we can derive the key. Now let me demonstrate that. So if we say, so we have a flag file which contains A's, and we have a key file which contains zeros, okay? And then we have the output here, which is 51 in hex. So if we go here, so as I just said, the flag contains, so the message contains A, right? And the key file contains 0, the character 0, and the result was, for the XOR, it was 0x51. Okay, so we have the message, we have the key, we XOR'd it, we got 51. Now what you'll notice is if we just had the message A and we just had the result, we can derive the key because we can do M XOR R equals K for key. And we can prove this if we go back and do the message. So if we did, so ORD is basically give us the decimal representation of a character. So in this case it would be A, XOR that with the result, which was x51, and we get 30, which if we make that a character is 0. So as you can see, we had M, we XOR'd it with R, and we got K. M was A, R was 51, and the result was the character 0, which is the key. Okay, so let's have a look. So what we're basically saying is, if we can know what the message is and we can know what the encrypted message is, we can derive the key. Simple as that. So what we can do is, if we can figure out how to make this key location 0, then we can use those first bytes that we use to encrypt the flag. Yeah, so let's try and do that. So basically, encrypt. So you have encrypt, which is called, and then encrypt will be called again with this value. So the next time, so the first time encrypt is run, it will run through, and then the second time it's run, it will use this key location on line 47 as the input, basically. So we need to make key location 0. So key location is stop, and then you can see here stop equals stop modulus key length. So modulus is remainder. So if we can do, like, if you do 4 modulus 2, you'd expect 6. Really? 4 divided by 2 is 2. Hang on, what is that? What? Hang on, 2 divided by 4. Oh no, sorry, that's an XOR. Yeah, so 4 modulus 2 is 0. Yeah, 4 divided by 2 is 2, remainder nothing. But if you had like 8 modulus 5, you have, yeah, so 5 goes into 8 once and you have 3 left over. So what we need is stop needs to be 50,000 basically. So if we do 50,000 modulus 50,000, that's 0, and that's, we want 0. So we need to make stop equal to 50,000. And to do that, you'll notice here that stop is the key location plus the length of the user input. The user input is something that we can control because it's here, right? When we go, is there anything sensitive in there? I hope not. Nothing too sensitive. I really don't want to start this video again. So yeah, that's all fine. I'm not scared about that. What data would you like to encrypt? Yeah, you can see here it says that's the, what data you'd like to encrypt, and these are multiple calls to the encrypt function. So this is being called again and again. Okay, so yeah, what we want to do is we want stop to be 50,000. We can't just put in 50,000 characters because we're also taking the key location, and the key location after the first call is 32. And we know it's 32 because this output is 64 bytes. And in hex you have two numbers, not numbers, two they're not well, they are numbers, aren't they? But it's from 0 to F. You have basically two digits which represent a byte in hex, and there's 64 digits here, so you know it's 32. It's a 32 byte flag. We know that. Okay, so yeah, on the first call this will be 32, right? So we need to do 50,000 minus 32. 50,000 minus 32. It's 49,968. This is what the user input string needs to be lengthwise. It doesn't matter what it is as long as it's that long. So if we do Python 3 print, let's just do A's, 49968. Put that into user input. And then if we open that, so on the first call to UIP, we're sending in that data, right? We then want to send in, for the second time round, this is when the key location will be 0, we need to give it some more data, like so. So we have 32 bytes of A's, okay? And now if we run this, Python 3 OTP, and we pass in UIP, you can see that this is the first pass. This is the output from the first pass to the encrypt function. This is the output from the second pass, and you can see in the second pass the key location is 0, and this is good because that means that the stuff that is encrypted here is encrypted with the same bytes that were used to encrypt the flag, which is what we want to interrogate essentially. So what we need to do now is, well, let's see if this is actually working. So we know the key is lots of zeros, and we know the flag is A, okay? So if we go back here, oh, here we go, yeah. So the message was A, the key was 0, the result was 51. And that was the case, wasn't it? If we run this again, Python 3, OTP, UIP, yeah, we can see here that it's 51, which is what we expect. So what we can do now is we can run this against the instance online, like so, and what we'll get is this output here. So this is the result of XORing the key with the character A many times, so 32 times to be exact. So we have a 64 byte string, which is essentially, this is a hex value, and it is the key, like the original key, XORed with A. So what we need to do is we need to undo that XOR operation. We need to XOR this result with A, with the A characters, and then we will get the original key back. And that's what we need to then use to XOR against this encrypted flag, and that will give us like the clear text. So if we take this value and we put it here, let's create a file. So this is the original key, but XORed with hex A. Sorry, XORed with A. XORed with A, yeah. So we put that in there. OG key XOR A, yeah. And then we need to know what is. So we have this flag, right? Sorry, we have this UIP, and this was entered on the second pass, these A's. We need to know what A is in hex. So we can do that like this. It's 61. So we can do Python 3 print 61 times 32, and then that is hex A. Okay, so we've got hex A and we've got the OG key XOR A. So let's take this. So now we need to XOR these two values, and that will give us the original key. So let's take that and then XOR. So it's from, this is hex, right? So we need to tell CyberChef that it's hex. From hex, XOR with this, and then convert it to hex. Okay, now that is our original key, OG key. Okay, and now with the OG key, we can take the key. Let's delete that. So we have this key. We can put it in here, and then we're going to XOR the encrypted flag, which is from hex. Yeah, it's from hex. We're XORing it with that key, and then this is the output, and this should be the flag. So let's try and provide that. picoCTF flag submit, and there we go. We have completed that challenge. Okay, so I hope this video has been helpful. Please like and subscribe. Leave any comments or questions below. If you need any further assistance, let me know in the comments how I've done with this one, because this has been a real challenge to explain. I've had to do this video a number of times, but I think we're there now, and I hope it's useful for you. Yeah, hopefully you'll see me in the next video. Goodbye.